Let's understand ratio using some real world problems. Suppose we have a class and the strength of the class is 30. There are 30 students, and out of these 30 students we have 12 boys. These are 12 boys, and we have 18 girls. Okay, so 12 boys and 18 girls. Now if we have to compare, the number of boys to the number of girls using ratio, right? Using ratio, that is, we have to compare using division. Then we know that in that case, if we have to find the number of boys to the number of girls, then that will be number of boys to the number of girls. It means it will be number of boys over 2. Its division sign means 2. Number of girls. Okay, this will be equal to, what's the number of boys? It is 12. And what's the number of girls? It is 18. So if we simplify this ratio, we know that it's a division, and in order to simplify it, we'll have to use the highest common factor. In this case, it's clear that the highest common factor is 6, and this will be 2:3. Okay, if we divide the numerator and the denominator by 6, so this will be 6 times 2 is 12, therefore 2. 6 times 3 is 18, therefore 2/3. That is 2:3. That is 2:3. This is 2:3. What does that mean? What does that mean? It means that for every 2 boys, there are 3 girls in the class. Again, this is 2:3. Let me copy it. This is 2:3. Remember, it's number of boys to the number of girls. That is number of boys to the number of girls. That is 2:3. I copy it here. This is 2:3. That is, for every 2 boys, there are 3 girls in the class. What does that further mean? It means that if we have a strength of the class that is 5, let's say there are only 5 students in the class, then there will be 2 boys, and for every 2 boys we'll have 3 girls. That is what 2:3 means. This is 2 plus 3. 2 plus 3 is equal to 5. This is 1, 2, 3, 4, and 5. This tells you the total number of students. Okay, so this ratio tells us that if there are 5 students, and how we got this number, 2 plus 3, this is 5, and 2:3 tells us that there are, for every 2 boys we have 3 girls. Okay, now this is the ratio of number of boys to the number of girls. If someone asks you that, okay, this is the condition when you have 30 students. Out of these 30 students we have 12 boys and 18 girls, and then you get the ratio 2:3, and on the basis of this you have drawn a conclusion here. What if you have the strength of the class is, let's say, 100 students? If the strength of the class is 100 students, now tell us what should be the number of boys and the number of girls if the same ratio has to be followed. Suppose from 30 students, you have to increase the total number of students, the total strength of the class is to be increased up to 100, keeping the same ratio, that is 2:3. That means that for every 2 boys, there should be 3 girls. What will be the new number of boys and what will be the new number of girls now? So in order to explain that, let's understand this in a very layman term, right? In a very layman term. I'll try to explain you this in a very layman term. Suppose you have this a bag, let's say that this is a bag, okay, or any container, okay, and in this container we have 5 balls. We have 5 balls, out of which we have 2 red balls and 3 green balls. So what will be the ratio of number of red balls to the number of green balls? Clearly this will be 2:3. Remember, this is a division by comparison which tells us ratio. So 2:3 is the ratio of number of red balls to the number of green balls out of this 5 balls. Now imagine that you have to keep the same ratio. You have to keep the same ratio, 2:3. And now you have 25 balls. Keeping the same ratio, 2:3. Now you have 25 balls. Now you have to tell what will be the number of red balls and what would be the number of green balls in that case. You will say that, hey, that's very simple. This is 5 balls total. And now we have 25 balls. Ratio is same, no worries. Let me draw it like this and we'll make it. So if this is 5 balls, Control C, Control V, one more 5. This is 5, 10 plus 5 plus 5 is 15, plus 5 is 20, plus 5 is 25. Okay, if this is 25, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have if 25 is a total number of balls, then we'll have 5 such containers, 1, 2, 3, 4 and 5. And you can get it by like this. If you add this ratio, that is 2:3, it is 2 plus 3. It gives you what? 5. It tells you that for every 2 red balls, you have 3 green balls, that is total 5 balls. And now you have 25 balls. So how many containers, such containers you will have? You will simply divide 25 by 5 because one container contains 5. So how many such containers will have? So if you divide 25 by 5, you'll get 5. Right? And that's what we have represented here. We have 5 containers, and the way we got is either by simply adding it, 5 plus 5 plus 5 plus 5 plus 5, or other way is directly, that is more, a mathematical approach, that is divide this 25 by 5 because the ratio is 2:3. That tells us that for every 2 red balls there are 3 green balls. So if one container contains 5 balls, that means the total number of containers now will be 5. Total container will be 5. Containers will be 5. Now, what would be the number of red balls now? What would be the number of red balls now? Total number of red balls. So you will say that, hey, there are 2 ways to find that. Either I should count, by counting it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's 10. Another way would be to find it is if one container contains 2 red balls, then if we have 5 such containers, how many red balls we'll have? We'll have 10. Okay. Number of green balls. Number of green balls. One way is to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's not a very good approach because in this case, the number is smaller, but had it been a larger number, then that would have been a problem. So you'll say that, hey, we can find using this method. In each container, we have 3 green balls. Therefore, if we have 5 containers, this will give us 15 green balls. Okay, same concept you are going to apply here. What we have been provided is that assume that this is a container, this is a bag. Okay, just imagine a group. If there is one group where there are 2 boys and 3 girls on the basis of what? This 2:3. Okay, so if this is one container or say one bag or a group of 5 students, out of which there will be 2 boys and 3 girls. Now if we have students, how many students? We have total number of 100 students. If there are total number of 100 students, then if you divide this 100 if you divide this 100 by 5, then you'll get what? You'll get 20. That means that you'll have 20 such groups, okay? I'll not use the term container because that will not be an accurate term to use. You'll have Control C, Control V. Okay. Should I make it like this? Control C. Control V. Okay. So you'll have 20 such groups, right? 20 such groups. Okay. So if strength of the class is 100, then if you divide this 100 by 5, that will give you how many such groups you'll have? 20. It means what? If one group contains 5 students and out of that 5 students there are 2 boys in one group, and how many total groups we have? We have 20 such groups. It means that we have 40 boys now. And if we have 40 boys, now what's the number of girls? This is the number of boys. Okay, number of boys. Now if we have 3 girls in each group and we have 20 such groups, that will give us 60 girls. Okay, number of girls will be this one. So what's the point? We have the ratio here. So if we add this ratio, it gives us 5. It means that for every 2 boys, there are 3 girls. That means that if the strength of the class is 5, there will be 2 boys and 3 girls. Now, if we have been given that there are 100 students now you have to tell that what should be the number of boys and what should be the number of girls. So you'll say that's very simple. We know the ratio, and by using this method, we'll find that okay, in one group there will be 5 students. In per group there will be 2 boys and 3 girls, and on the basis of that, we'll find out how many such groups can there be. And then if we divide this total number of students by this 5, it will give us how many such groups we will have, and then on the basis of that we can calculate the number of boys and the number of girls.